Last week we went to Louisville to the national no-till thing, which was kind of interesting. We thought we'd get nice weather, and we got lots of snow and cold weather, so it wasn't worth the trip. But that way, but I did get to go see Churchill Downs, which I've been on my list for a while to do, and it was all covered in snow and things and kind of cold to tour it. But as we were touring it, the tour guide pointed out Secretariat, which I'm one of the guys that's still old enough to remember when he ran. And I knew that he had set the records the year he ran in all the three races, but he still holds all those records. And I knew that his heart was a little bit larger than a normal horse, because they had kind of figured that out before he died, but I didn't realize that when he died, they autopsied him. A normal horse has a heart about 7 pounds. His was 22. So I kind of went, oh yeah, that might be the hidden thing there. So got a lot to cover this morning. I'm not sure. Okay, I'm not sure that's on. Some of it's good news, some of it's not, but I think we as farmers need to start taking control of some things. Fires in California, fires in Brazil, fires in Australia, fires in Colorado, Oklahoma, in Kansas. Floods in California, floods in British Columbia, floods in the Corn Belt, floods in Australia, tornadoes in December. Aquifers that are overappropriated. Rivers that are overappropriated. Lakes, rivers, and oceans that are degraded. The number of and extent of hypoxic zones in the world's oceans have doubled every decade since the 1960s. That's scary. We, all of humanity, have a problem. And I think we need to start realizing we have a problem and do something about it. What are we going to do? I put this in because I'm married and have 3 daughters. Even a man would have to ask for directions, right? If you have 3 daughters, you have a totally different view on life. Circular biological systems were replaced by linear systems focused on extracting resources. We've been doing that since Europeans came to the United States, extracting and exporting. And our focus is really hard on exporting right now, and we're all happy that we do all this exporting, but what is the long-term consequence of that? Development of coal and other fossil energy meant that lack of energy was no longer a limiting factor for shipping things out. So when we started doing fossil fuels, is that doing that on its own, or am I doing that? Seems like it's moving around. Huh? Okay. Producing 2.3 million tons of steel annually with wood in the Great Britain in 1850. That's how much they produced. Would have required cutting a forest of 97,000 square miles every year. If they didn't have coal to get that many tons of steel, they'd have to cut 97,000 square miles. That's greater than the total surface area of the UK. Next slide, please. We had somebody back there? Use of fossil fuels has allowed society to ignore these feedback loops that would limit degradation. So if we didn't have the fossil fuels, we would get these feedback loops and we couldn't produce that way, and we'd try something else. Next slide, please. Native American communities in central South Dakota before the introduction of the horse were agriculturally based in mixed cropping and hunting. Just between Dakota Lakes and Pierre, there's a fairly large Native American farming community that was on the hill there. And they were growing corn and squash and beans and those kind of things. There wasn't, you couldn't chase animals around if you were on foot very well. So you had to be farmers. Next slide, please. The Lewis and Clark expedition purchased corn from Native American farmers near Bismarck. The farms were abandoned in South Dakota by the time they got here, but by the time they hit the North Dakota border, they started seeing farming communities. They saw evidence of farming communities when they came by, but they were abandoned. When the animals were removed and replaced by tillage-based farming and overgrazing by domestic livestock, we had severe degradation occurred. Next slide, please. How long did it take? Well, the time frame between statehood, 1889, and the Dust Bowl was 50 years. And less than 50 years separated statehood and the Dust Bowl in South Dakota. Next slide, please. Degraded soils and loss of beavers resulted in dust storms and crop failures, while at the same time severe flooding was occurring on the Missouri River. So during the 30s is when we got the big floods that caused them to start building the dams. Next slide. Pick Sloan project, 4 big dams in South Dakota, 500,000 acres of planned irrigation was supposed to come here, which would have been the stupidest thing in the world, to come here and dump a bunch of irrigation water. It wasn't the problem, not having enough water. The problem was we weren't using it right. It was running off. Water cycle was broken. Next slide, please. The water cycle was broken even after we built the dams, and putting in the irrigation wasn't the solution. Next slide. So who or what is responsible? Next slide. You can say we didn't know. That's what everybody said. Oh, well, we really didn't know. Well, we did know. Plowman's Folly. Next one. Conquest of the Land by Loudermilk. The Worst Hard Times by Egan. Dirt by David Montgomery. Civilization Critical by Darren Qualman. We did know, and we do know, but we do not want to change as a society. Every time I talk about change, people go, oh. 30 years ago, when I was, or over that, when I was at Redfield 40 years ago, and we start talking about doing no-till and stuff, everybody go, oh, that'll never work. Boy, that's stupid. Gotta till this ground, make the water go in the ground. Do that, but stupid damn PhD guy. Okay? Next slide, please. Present government, economic, and social systems favor degradation over regeneration. You think that you're doing the right thing because everybody's happy with what you're doing, but they want to export stuff. The people that are really making the money are the grain companies and the railroads and the export shipping things. And they want that balance of trade so we can buy cheap TVs from China and send them grain. Total subsidy for crop insurance in 2013 was $14 billion. Total federal budget for all agriculture research on the federal side was 2.6. Think about that number, 14 billion for subsidies, 2.6 billion for research. Makes no sense to me. I use those numbers because in 2014 we were talking about Obamacare. And I gave that data to people in Kansas at a meeting, and I said, if you think subsidizing crop insurance is a good thing, then you have to believe that subsidizing health insurance is a good thing too, because you can't have it both ways. And I'll say the same thing now. You have to decide what you want. Total direct subsidy for agriculture in 2019 was $22 billion, in addition to crop insurance subsidies. Can we defend that to society? Can we defend what we're doing? And what happens to that money? It gets capitalized into land costs. Okay? Robert Parlman is at Harvard, teaches economics. I rode between Rosario, Argentina and Buenos Aires, Argentina with him one time, which is about a 3-hour drive, and spent a couple hours in the airport before our plane took off. And he's one of the main people everybody looks to for ag policy in terms of economics. He knows that this is what happens. He said, we know that it gets subsidized, it gets capitalizing land costs, but everybody seems to want it, so everybody gives it to them. So they sold land in western Sully County last month for over $6,000 an acre. Who gets the money? Next slide, please. So where are we going? Next slide. Obviously, we need a different model for agriculture research and policy. And ag research right now is a mess in general. Next slide. We think Dakota Lakes and that model and the one for the James River Valley Research Center is the right thing to do. So this is Dakota Lakes. Yes. I usually bring my own. It's kind of like playing pool. You don't play off the wall with anybody but friends, right? And I usually bring my own, and I didn't today. So this is a native vegetation at Dakota Lakes. Soil health, which this group is focused on, is not a goal. It's the result of good ecosystem management. It's not a goal. We shouldn't set out to do soil health. We should set out to handle our ecosystems better. Again, the large four dams in Missouri River did not fix the water problem. Dakota Lakes happened partially because of those dams, but partially because we didn't fix the problem with the dams. This is a irrigator putting on high pressure, water at high pressure, which means about an inch every 30 minutes or 40 minutes. And that's what happened. Danny's getting tired of me showing this picture, aren't you? Yeah, that's Cronin's pivots, and I was in the plane with Dan Cronin taking that picture. So, but Dakota Lakes is owned by farmers, and they drive the operation. And I'm not going to spend a lot of time on that. But what has happened in the central part of the state, these three north central, and south central crop reporting districts. And Dan and I calculated this in 2014, $1.6 billion difference in crop production compared to 1986 in 2014, which are almost identical rainfall years. And we used the price August 12, 2015 for both of those years. But we didn't achieve that because we set out and said, gee, we're going to make more yield in central South Dakota. What I was trying to do was to stop the bleeding, stop the dirt from blowing and the water from running and those kind of things. That's what we were trying to do. Because I had taught school in Gettysburg in the 1970s. Actually, one of my students is in the audience someplace, unless she snuck out and went shopping. There she is. She really wasn't a student of mine, but she had a locker right by my door, right? You were a senior, and I didn't have any seniors that year. But so that's always kind of scary when you have students in the audience. But the thing we did is sometimes called transformational or stupid. The light bulb did not result from incrementally making candles better, and I took that from Jay Fuhrer, who said he took it from somebody else. Most present systems, however, are just only slightly different than what we did when we did conventional tillage. Now, Sam Ireland's here someplace. Where's Sam hiding? Over there. Sam's going to be replacing me next week. He's going to be the new manager, so we kind of kitty-cornered through from Pierre to Aberdeen and looked over the countryside and talked about history and whatever. But there's quite a bit of residue there, but a lot of that residue is soybeans, which scares me if we stay dry. So most of these systems are not all that much different than what we did before. We just really quit beating the ground, and it's better, but it's not quite there. We got to go further than that, and I'm going to throw some things out today, and it's a little bit like John Kennedy when he said we're going to put a man on the moon in 10 years. He didn't say we're going to make rockets a little bigger and then see someday if we get a big enough rocket if we can get to the moon. He just said we're going to go to the moon, and now you scientists and engineers, I want you to figure out how the hell we're going to do that. Okay? And that's really the kind of attitude we need to have. The increase in production I showed you there is mostly crops destined for export. Like I said, that's not the right answer. This means they're mostly just doing the wrong thing better. The wrong thing is exporting everything. We're doing it better than we did before, but still not quite where we should be. We need to be more cyclic with what we're doing and not so much import-export. No-till similarly is not a goal, it is a tool needed to properly manage an agricultural ecosystem. No-till is not a goal. So cycling is the title for today: water cycle, energy flow, mineral cycle, community dynamics. Regenerative agriculture, Ray Ward told me the other day that's not the right word anymore because it's been overused and everybody's starting to hate it. We've used this term for quite a while, and it means that we match all these natural water, energy, mineral, and dynamic or diversity cycles that existed before we got here. And if we do that, we're going to be okay. And we try to make it do what we want it to do, it's going to continue to degrade. So does rain feed plants and recharge groundwater? Does it run off or deep percolate, cause erosion, water quality degradation, or go down a drain tile? Because it goes down a drain tile, it's really in the wrong place. Again, Danny's picture. We can now put on 2 inches of water in 9 minutes with our irrigators and walk right behind those machines. When I was at Redfield, we did the same thing. On these lacustrine soils, once we got them functioning, we put on an inch of water and went out with a drill and drilled it and invited all our neighbors to watch us, and they thought we were totally nuts because the irrigator went by and I pulled in and started drilling. So you can make these soils in the Jim River Valley are different if you live in Jim River Valley, but you can make them way better if you no-till them properly. Most guys aren't quite doing that right. So no runoff, 2 inches of water in 9 minutes. It's not about lack of tillage, but managing these other things. Ecosystems harvest sunlight energy to drive all other processes. Removing products from the ecosystem reduces the energy for the biology that's in the soil. We can't take corn stalks and make boards. You're going to hear about this pretty soon. Somebody's going to try to buy your residue to make boards. It's just trash anyway. Well, that's been going around for 30-some years. They're going to make paper out of it. I told some lady from Canada, you can't have my residue, make your damn paper. Right? It's something I got to have. Is the energy used constant or finite? In other words, is it going to run out? Is it benign or potentially damaging, internal or external? Well, fossil fuels are finite. They're going to go away. They're damaging to the ecosystem. You know, our CO2 is going up. It's getting hot. They got up in the mid 40 degrees Celsius in Argentina last week. That's like 116 degrees. That doesn't happen there. Is it internal or external? If you have to buy it, or is it your own? Well, sunlight you can harvest. It's internal. If you have the land, you have the sunlight. It's yours. You don't have to pay anybody for it. 80% of the total input costs in agriculture can be traced directly to energy at the present time. Fossil fuel input in agriculture 120 years ago was zero. And it's going to have to be zero again before 120 years. We need to get the energy out of there. I mean, we're producing these great crops. We're taking oil and turning it into crops. We got to make sunlight into crops. Why? 1970, the average wheat price was $1.37 a bushel. The average price of a barrel of oil was $3.39. I'm really excited. I can get $8 now for wheat. For a while. How much is a barrel of oil? 80. Is this a good deal? Is this relationship going in the right direction? Right? I mean, come on. Takes the energy of 1 gallon of diesel fuel to manufacture, transport, and fly 5 pounds of N. 150 pounds of N is equivalent to 30 gallons of diesel fuel. Boy. Use of inorganic nitrogen fertilizer was essential zero prior to 1950. It's 100 million metric tons in 200 to 210. Not a good deal. That's more oil, right? Use of Dakota Lakes Research Farm will be fossil fuel neutral by 2026. Notice I'm getting out of there before 2026. So if we don't make it, it's Sam's fault. We started this a long time ago. This year we put up the solar panels. We already have our Ford Lightning pickup ordered. We already are converting our one side-by-side to electric. They'll all be electric. Because when we put the solar panels up, we can meet the needs of our shop building and offices and whatever with the solar panels. All but 2 days a year we'll have excess energy. And we can use that energy to make fossil fuel or make nitrogen if we want to. But we're going to use it to do these other things first. We do not have a choice. It's kind of like if you go to the doctor and he says, well, you've got a blocked artery there in your heart. You're going to have surgery. You don't negotiate. You go, yeah, okay, shit, right? Don't have a choice. That's where we're at. And we're talking around this like there's a choice. There's not a choice. We've got to quit using energy like we're using it now. So we're pressing our own oil seeds. We've been doing that for a long time. We can burn those. If I lived in Germany, we can burn those in our trucks and tractors. That will come here. The politicians will get their whatever and get their attitudes adjusted, and we'll be able to buy those German-style engines that you just dump this stuff in and burn it and go. So total energy used on Earth in 2012 was 560 exajoules, or 1.6 at 10 times 10 to the 13 kilowatt hours. Got that memorized? There's going to be a quiz. Okay? All the energy that was used on Earth that whole year is that, right? Remember that number. 86% of that was the non-food energy in there was fossil fuels. Estimates of the total solar energy at the Earth's surface range from 1,600 to 40,000 exajoules per day. Per day. That other one was year. 1 day of sunlight is 400 to 800 times as much energy as that used in a whole year. What's the problem? We got lots of energy. All we got to do is figure out how to harvest it. So why are we afraid of that? Because we're being told, oh God, you guys, if you don't have fossil fuels, if you don't support our oil companies, you're going to be cold. Right? You seen those ads? Oh, aren't you glad you got fossil fuels today? We will continue to use energy. It's key to our standard of living. We just need to change where we get it. Mineral cycles are the nutrients available for plant use for environmental services, or have they been leached, eroded, or transported from the landscape, sent to China or ocean? Ecosystems that leak nutrients including carbon, turn into deserts. 120-car train of soybeans contains 400,000 pounds of phosphate. Every time, we were coming up here yesterday, and I said something to Sam about these circle loaders. He's from Martin. He didn't know what the hell a circle loader was. They don't have any of them out down there. He said, you mean they put a whole train in there and fill it and it goes away? And I said, yeah, it takes 400,000 pounds of phosphate with it when it goes, every time. The governor likes to stand there and cut the ribbon in front of those. This is progress, and I'm not sure it is. If it goes to the saline seep, or it goes to drain tile, it means we haven't used the water right up the hill, right? So if you've got problems with that kind of thing. A reduction in pH, organic matter, and fertility are symptoms of poor nutrient water cycling. Montana, they have a big problem with low pH. Sam did some work in Montana, so this is right down his alley. I had somebody east of Great Falls take some soil samples out of wheat fields and out of neighboring CRP or grass. So the wheat field have, on the bottom there, they had pH of 4.9 and 5.1. and lower organic matter. And the grass right next to them is 7, 8, and 6,4. And then look at the calcium numbers, 4,000, 2,400, 850, and 300. They just let that lime, calcium carbonate, and gypsum, calcium sulfate, go down and go sideways and become saline seep someplace. Or go down and go in drain tile and go away. Go talk to Nick Ward. They do sample analysis for people out of Ohio in their drain tiles. Just amazing how much stuff goes out of there. Why would you want to ship that to somebody else's waterway? Why would you want to buy the nutrient back from the fertilizer dealer instead of using your own? And when people used to come and visit us at the farm from Watertown, well, they still do, but the students, I ask them what's in a saline seep, and if they say salt, I get mad at the teacher. Jim Clendenin can tell you about this. It's fertilizer. The stuff's in it, the fertilizer that's gotten into the saline seep. We need to rethink all aspects of agriculture and society. Trying to export more products is probably not that right answer. In 1973, the Soviet Union was a net importer of wheat, with the U.S. being the primary supplier. And there's probably 5 people in the room here, or 10, that remember that. Earl Butz going, farm fence row to fence row, and we're going to sell our wheat to the Russians. Right? That's when we broke all the land West River and whatever to sell this stuff to the Russians, right? In 2016 and 17, Russia became the world's #1 wheat exporter. So much for Earl Butz's plan, right? They use the same technology we do. The big companies don't give a dang who they sell it to. They sell them John Deere drills, and they sell them chemicals and fertilizer, and they're fine with that, right? And they're the #1 exporter, 28 million metric tons. 2017-18, Russia exported 41 million metric tons, and Ukraine, which in 73 was part of Russia, and I hope it isn't again, exported 18 million metric tons, right? Total production in the U.S. was 47 million. That's less than Russia and Ukraine together exported of wheat. And we exported 25 million metric tons. Make sure when you're doing decisions about fertilizer placement and those kinds of things that you look at what the plant root looks like. This is a corn root. P is a dominant source of P for the seed is a dominant source of P during V1, up until when that thing perceives light. No fertilizer nutrients needed, but could hurt if we had too much N and K2O close to the seed. At V2, soil becomes the dominant P source, and the plant in demand for the P is the highest right then, is at that V2. But where are the roots coming out on that plant? The seed has that radicle and a few little roots there. Most of the roots come out between the seed and the surface of the soil. Same is true for wheat. And when people visit in the summer, I always dig up a mature corn plant. And I find some guy in there that's a strip tiller. Right? And I dig it up, and then you tip it over, and you see the seed right there. You tip that big root system over. Right in the middle is the seed, and there's no roots underneath it. They come out and go down like an umbrella. And I go, why are you putting all your fertilizer down here where there's no roots? You know, did Brian Hefty tell you to do that? I mean, who told you? We have a lot of fun with this, because it's, why are you doing that? You want it at the same depths as the seed, and you want it about 2 or 3 inches off. That's where those roots are going. If you're thinking this year, God, I can't, what am I going to do with fertilizer? The one thing you're going to do about fertilizer is you're going to make sure you have nitrogen close to that corn seed early. And then at V6, go and re-soil test. Get to know Nick and Ray Ward. Re-soil test at V6 and see where you're at. And if you need to V5, V6, if you need to add more, but then you can maybe buy more, cheaper, but at least you know if you need it. But you put some there at planting, okay? P status at V3 and V4 influences kernels initiated per ear, so you want that phosphorus and nitrogen, that 2 inch to the side band is what you want. Okay. So we've been doing this for years. This is our first original concept seeder, but we've been doing this when we were still doing the old ridge-till type seeder. We move a little residue if we have to, but the big thing is we put the fertilizer 2 inches away. We leave all that residue. We're not throwing a bunch of dirt around. We want to leave that covered so that it keeps the weeds at bay, and we don't want to put any fertilizer there. But you can see 2 inches away from that, those 2 trenches are 2 inches apart or 3 inches apart, and at the same depth, because that root goes sideways. Okay? That root's going sideways there, right underneath the surface. Or you could do a Marion Calmer and plow. Never mind. That's a national no-till joke. There, that's what it should look like. And that's pretty easy. We've done, I think the response to strip till, and I've got a whole series I could do on that, has to do more with not having the right closing wheels. So unless you've roughed the ground up a little bit, the standard closing wheels don't work. So we have these different systems that we use. There's a lot of them out there for different closing wheels. And here's our machine going through planting corn on corn. That's okay. We can clear that fine. We try to leave this in place to keep the weeds down until we get a new canopy, because the best weed control is a good canopy. I'm going to show you real quickly. These are on our website, all these, so you can go on our website and look at them. Here's strip till, no-till 1, and no-till 2, or strip till 2 and then no-till. What regular strip till was is they put fall phosphorus on plus pop-up, and they got better yields. And I told them that's not fair, so they did another one where they didn't put the fall P on with the machine, and then the no-till beat it. And this was done in Redfield in 2002. But these are all on our website, and very consistently we get a response to nitrogen placed with the seed versus the surface. Here, if we put the 28% on the top, 194. If we put urea to the side, 207, 202, 197. Urea in the side, all those consistently higher. If you put it on top, it's down to 200. And you can look at every one of these. It's very consistent, does that. If you put that fertilizer in the ground close to the seed, you get a response. Or you get a response to lower moisture. And this isn't just us. If you look around the Corn Belt, they did 11 studies. In conventional tillage, only 1 gave a response to starter. And in no-till, 8 out of the 11 gave a response. So it's probably something you didn't have to do when you're conventional till, but maybe now. We don't get much of a response to phosphorus. And here, this one's on there too, but if you look at, again, the N over the row or N in the middle, those last 2 are 20 bushel less. Here, all the nitrogens we're supposed to do, and we look at where we put the phosphorus, and we don't see a whole lot of difference there. We don't get much response to phosphorus. So if you're looking to save money and you've been a long-term no-till guy, don't do much phosphorus this year. Put a little bit in close to the row, and the rest of it forget. If you've got even low testing soils, if you've been long-term no-till, and with some rotation. Here we have an Olsen P of 5 parts per million. 5 to 6 parts per million, right? In our tissue, phosphorus doesn't really change. If we put it on the surface, it's not as good as if we put it in the band. See? So you band a little bit of phosphorus on there, and the rest of it you don't have to do. The reason for that is we have a lot more mycorrhizal fungi there. We haven't put any fertilizer on, broadcast fertilizer on. We have 2 to 6 times as many mycorrhizal fungi there. So here's uptake. Total P, we have a lot of P out there. I told you we had 5 parts per million. You could, when you send a test into Nick or Ray Ward, just have them run total P and whatever, Olson or Bray, depending on what your pH is. You got a lot of P there, you just don't have a lot of soluble P. So if you have low testing soil. Well, how come when you go to the Black Hills, the trees grow out of the rocks? They have mycorrhizal fungi. Okay? So leave your mycorrhizal, don't do tillage. Okay? If we, nutrient management will need to become more cyclic. It's presently very linear. So we're trying not to export this stuff. We replace what we sell. Nutrients are applied and exported somewhere requiring continued new inputs. The proportion cycled within the system needs to be increased, and the portion exported needs to be decreased. So some starter P with the seed, or with weed, or in proximity to the seed with everything else. Other nutrients placed near row or at seeding or on soil surface after crop canopy. Broadcast fertilizer before at seeding encourages weeds. But think about this, available nutrient, moisture, and roots, put them all in the same place at the same time when they need to be there. I'm a farmer, take sunlight, water, and carbon dioxide and make them into products I can sell. Focus on having the soil wet during the dry part of the year. Everybody wants to be the first guy seeding, so they beat it all up so they can get it in, you know. I got a neighbor across the road that always does that, and people come to visit me in June. And they go, well, his corn, it normally isn't anymore, but it used to be bigger. And you go, well, his corn's bigger than yours. And I finally just learned to say, oh, you harvest corn in June? And I turned around. Looked very confused when they said that. Instead of just focusing on having it dry during the wet part of the year, focus on having the soil cool during the hot part of the year instead of focusing on having it warm during the cool part of the year. And when you get these hot years like we're getting now, it's great to have that residue to keep things in control. They're important for irrigation. They're imperative for rain-fed farmers. Just going to show you how rotation impacts. This is a low residue rotation we now have quit doing. Every other year broadleaf, which is what a lot of people are still doing. That's too much, broadleaf. This is the wheat. This is a 2006. This is the wheat in a rotation. It's 2 years out of 3 high residue. You can see it on the aerial map. The yields, 60 versus 29, 7.9 inches in 2006 between when we harvested peas and when we harvested winter wheat the next year. Even in a wetter year that started out dry, we're almost twice as much. And you can see that very consistently, these low residue rotations. In the middle there's 60, the ones with higher residue, 95, 80, and 95 and 87. Agriculture cannot do this alone. It needs society to have a brain transplant. Ecosystem degradation is a symptom. Indifference, greed, jealousy, selfishness, ignorance, hubris are causes. First time I went to Argentina, they were doing 7 years of pastures and 7 years of farming. This is what the soils look like. They did cover crop on the left, and near us without cover crop, there's quite a difference there. But that's what the soil looked like. If you need a definition of soil health, take that picture. But then they outlawed the export of beef. And everybody quit doing cows, and they started doing all soybeans. And I went back there 6 years later, 2006, I think, maybe 10 years later. That's what that same field looked like. Because he's just been doing mostly beans on beans on beans and occasionally corn. Organic matter makes a difference. These are my daughters. They're all way bigger than that now. They're all self-sufficient. It's really nice. They have their own money to shop with. Anyway, but that's a prairie plant. That's what we replaced. That's the roots on a prairie plant. That's in the Museum of Man and Nature at Winnipeg. But look at these root systems, and we put in a corn or a soybean or a wheat plant. It's not even close. I think we're going to have to do perennial sequences in time. So that's my cycling talk for today. And we got the technology working. I don't know when they're timing me out, but I'm afraid of Cindy. She's grumpy. If you go over time, you should be grumpy. Okay. Yeah, I can take some questions if you want. You got to have some questions there. If, this whole fertilizer thing, get a soil test. Get a good soil test. And go deep. Get the 2 foot or 3 foot. And test that nitrate there. It was a dry year last year. You're going to have nitrates there. You don't have to use that fertilizer. That's there. You own it. It's yours. So go and get the deep soil test, send off, get nitrate test, sulfate test on that deep samples. I don't care where you send it. Make sure they're running the right samples, and don't necessarily listen to their recommendations. Now, if you're sending it to wards, I know they use SDSU recommendations, and maybe a little bit more conservative than some SDSU recommendations. Some of the other labs are not. They think, well, you got to build, Fred. You got to build your phosphorus. Why do I have to build my phosphorus so it goes to the river? I don't need to do that. I'm a no-tiller. Okay, so, yeah.